Hi, I'm Samir Jain. I'm a third-year undergraduate BME at Georgia Tech, and I want to talk today about using 3D printing with hearing technology. So there are two main branches of hearing technology. There are hearing aids and there are cochlear implants. Hearing aids simply serve to amplify sound. Cochlear implants take a different approach. They take the sound, they process it, and then send it as electric signals to the cochlea and the brain itself. And this works with an electrode array which is pushed through 1.5 turns through the cochlea. And on those different locations of the cochlea, different parts of the cochlea can be stimulated to represent those different frequencies the brain can understand sound. However, in the process of doing this, while the wire is being pushed in, it can cause damage. The yield forces of the cochlea are very low, they're around 200 millinewtons, and that is lower than the force it takes to break a mechanical pencil lead. So one way to prevent this from happening is making sure that the process of pushing the wire in does not happen. And we can manipulate the tool that is used for the wire itself. There's a standard claw that's used for surgical placement, and what we're going to do here is we're going to make sure that the bottom part here is going to bend before you reach that yield force. So we have information about the dimensions, and we have information about the yield force we want, so we can take advantage of all those formula for buckling to understand the Young moduli for the property strength that we're looking for. So we sketched some ideas on the computer, and we found that we want it to be similar to the dimensions of the original claw, and just make sure that it's stiff. So we printed them. These are the two main prototypes that we got. On the left is a print that did not have a high quality ink, and as a result, it could not buckle properly. The tip was not very structurally stable to even stay straight. On the right, we used a different ink and a different printer as well to make a material that ended up being a lot stiffer and could buckle to an extent. So there's a lot more work to be done here, but we can discuss what this means for us. We know the printers are capable of printing that detailed resolution. This Cochlea model, for example, was printed, and it has the detail resolution to be able to print a nice curve at a big scale, but also to be able to print at that small scale. This prong here actually has details of less than 1 millimeter. Also, we can understand how to manipulate those different 3D inks to create those specific properties, to create those specific thresholds, so we can have them tested by different yield forces, surgeons can practice with them, and maybe even potentially use them in an operation room. And this is just a small sneak peek of what 3D printing means to us. It can print for cheap, and it can just make trials. You can test medical devices for very cheap. But what is 3D printing? 3D printing is the idea where you sketch up something on the computer and you send it as a digital model to a machine that takes up this model and prints it. And it prints it by dropping pieces of Play-Doh from the top onto the bottom, and layer by layer you get what you want. And this is just the start of something new. We can build houses, we can build hospitals, we can build medical devices just like this one, and you could create spaceships that repair themselves. What will you come up with? So what does 3D printing look like? We have an industrial printer here which is about the price of a car. However, if you have a MakerBot that's about the size of a laptop and it's about $1,000, you can find them in your schools and your libraries. So to get an actual print, you need a model. And where do you get a model? You can get a model from online sites like MakerBot, Thingiverse, have thousands of designs for you to play and work with. Or with some practice, you can actually draw them yourself with CAD. CAD is computer-aided design software. So for my personal project, I wanted to work with a cochlea. So I got an MRI scan from a hospital of the middle ear cochlea, and it's as accurate as this model can be. So I printed it out, and the way it's actually going to work is different from how we expect. Normally when you want to make a model, you want to make a sculpture, you have a block of wood, and you take away the parts that you don't want, and that is called subtraction. 3D printing is all about addition. When a 3D printer receives a model, it's going to look at it, examine it, and analyze it, and then it will slice it down into the smallest layers that it can work with. And it's going to work with a platform and a nozzle, and it's going to move around until it makes that one layer at a time, moves up, and continues making layers. So give or take a few hours, you get the finished product. So the 3D printer, when it analyzes the model, It'll build in the spaces that it makes for structures to help build the rest of the model. So the black stuff here is used to help stabilize the rest of it. And then afterwards, the black stuff is actually washed away, cleaned off to get your end result. The end result of a Cochlea print will give you this. If you look closely at the Cochlea, you can see the layers that the 3D printer actually sliced it down to and then built from bottom to top. So a 3D printer isn't just limited to those things like a Cochlea with the models from online. I hope this video gives some ideas about what you can print, and there's a whole infinite array of possibilities of what you can do with it. Thanks for watching.